everyone speaks about it. So, what is that self-driving car means? What are the features are there? Can anyone tell?
We can say that it is using automatics, or it is traveling by itself. So
Okay.
driver is not using this hand, so the steering and all it is controlling by AI
Mhm.
or ML. That is one
Okay.
feature.
Okay. So I can see that it is driving by its own, and if you see the this is the right side panel, and if you see here, we can see that multiple things are getting boxed. If you can see this, there are blue color box and some red color lines, and there are some green color objects. So that is something that is getting detected, which gives the direction or which gives the idea of the object available while the car is driving. Now, when you say that if you are a driver and if I put, uh, let's say, a cloth on your eyes or let's say a belt on your eyes, and if I ask you to drive blindly, is it possible for you guys? Just close your eyes and drive the car.
Yeah, it's not possible actually.
It's not possible. So that means there is something called vision is very much important when you are driving, right? So when you are driving, you see many objects passing around you. When you are driving, you can see that the road is going where it is turning, where there is a road, where there is object, where there's a let's say animal or human or whatever. So for that, you have eyes and you can see those objects. I mean, you use your eyes, you use your brain, and then you analyze, okay, there is a object, there is a person standing, or there is a animal, and then you need to take a decision that which direction you need to take your car, or let's say whether to apply brake, whether to apply immediate brake, or whether to decrease the speed of the car, whether to increase, accelerate it. All these decisions are depend on what you see and what you analyze. So that is the importance of vision as well as a brain. So it's not only that you see, and because if you see and you are not able to act on it, then whatever vision you have, that doesn't make sense. So to make it sense, you also need to have a brain. So the combination of vision and the brain gives you the ability to drive a car. And similarly, needs to be done on the self-driving car. But here, you are not a driver. There is something else, or let's say some machine, I can say, which is seeing as well as taking decision on what it is seeing. So let's jump to the next. That is what just now I have explained, that human vision versus a computer vision. Now, as I explained that how human vision works. So when I say human vision, vision is not only what you see, it's also about what you analyze on top of what you see. So you have eyes and you have brain. We all have eyes and we have all have brain. So what you see from your brain, you start interpreting, start analyzing, and then your organs take decision on that. I mean, they don't take decision actually; they do the action. But your brain gives the order to your organs so that you do the whatever order is. So here you can see that the human vision system is showing that there is a picture, you see it, you analyze what is there in the picture, and let's say you can see and you can say that okay, there is a bowl. Inside bowl there are fruit, there are various fruits like apple, we have I guess lemon, we have oranges, we have bananas. Yeah. So by looking at this picture, you can easily tell what are the fruits. You don't have to read this. Okay. You just can see that and answer. So similar things you are expecting from the computer. Now, how computer is going to do it? You have eye and you have brain. What computer has and how computer can achieve that. So for the similar case, What computer can do is you have the sensing device that can be camera, that can be webcam, that can be your any mobile camera or whatever, or CCTV. Nowadays we use CCTV. So whatever the CCTV or camera captures, it needs to get interpreted through some device or through some machine. Now this is something camera is using as a sensor. Camera is used as a sensor. Device is used as a brain. So here camera plays an important role of eye, whereas device or the machine or any kind of a model, let's say, uses the brain role, and then you get the interpretation. So I hope this gives us a little bit idea about what is computer vision and how the computer vision work. I know it is not deep, but it's very super, I mean very superficial, and I hope we all are understanding. Just give me thumbs up in the chat so that I can understand you guys are following with me. Good. Okay. Okay. Yeah, Venkatesh.
No, no, I'm just giving you thumbs up.
Okay. Okay. Okay, Venkatesh. Thanks. So let's go to the next slide. So now let's understand in a deep that how computer vision works and what are the steps. So before getting into how it works, let's understand what are the steps in computer vision. So as I said that in the last slide, computer needs to collect the image or captures the image, or let's say capture the video. So for that, what computer vision needs is image acquisition. From getting the image, let's say sequence of images, it gets like a computer, let's say computer here, it gets sequences of images, and then it needs to go to the next step is called image processing. So once you collect the image, once the computer collects the image, it processes on that image. What processes happens on the image, that also we are going to see in this session. But let's just understand the basic steps. So it starts processing the image, and at the end, it starts understanding the image. So after the processing, why we do the processing over here is a simple answer that computer will only understand in numbers. So it won't understand the object exactly. It won't understand that, okay, there is a red color apple over there, or there is a green color apple over there. It can only understand numbers. That we all know how computer reads the thing or how computer visualize the things. So that is why the image processing step is going to be involved over here. And at the end, whatever the process happened on the image it has received, it will try to understand by taking help of some pattern recognition or some other ways. It will start understanding the image. It will start interpreting from that image. So let's go to the next. So here we are going to explain, because now we saw that there is a step called image processing. Let's go to the image processing in deep. So guys, you can see the left side, there is some image. Do anyone have any idea what exactly it about? Any idea? It can be correct, it can be wrong. That is not a problem. Just speak up.
Just dividing a pixel into multiple in image.
Good. Yeah, you use the word called pixels. That is very important word, because the whole computer vision worlds revolve around these pixels. And if we know pixel, we can know it better. So what is pixel basically? Again, anyone?
So just a small square box.
Yes, correct. It is a small
But
element.
when
Let's say I
that
can say
element and
smallest. Yeah,
element in a picture and it is representing the color or like the colors fill on it actually.
absolutely correct. Yes. This is the exact answer of what pixel is. This is an element. Let's say it's the smallest element in the picture, which represents the color. Yes. Or maybe the brightness, color as well as brightness. It can be color also. I mean, color itself is a brightness. Like if you see like from less bright to the brighter, you actually sees the color change. So yeah, it gives you the color. So here you can see the small pixels, small squares. These are nothing but the pixels. And now what image processing is that the machine interpret the image in the series of these pixels, and each pixel is going to have a value. Now this value is very unique. How this is unique? That it ranges from 0 to 255. So let's say here it is a black and white. I can say black and white, I can say grayscale, saying that we just can see black and white over here and shades of gray, correct? And from here you can see, because it's very small, I can read it for you. So something it is here 157, 153, 174, 168, like those numbers are there, but these numbers are always going to be from 0 to 255, and these are range. Let's say a 0 is considered as a black and the 255 is going to be pure white, and the middle numbers from let's say 1 to 254, these numbers are nothing but gray shades. So you can say like somewhat gray, then dark gray, or very bright gray, or maybe dull gray, or something like that. So you can see there are different numbers. I can say here there is a 0 where there is a jet black, there are 0. When there's a pure white, there is 255. And from these numbers, it is going to convert the whole image into the matrix. Now matrix is nothing but it's like an array. It can be 2D array. Yeah, I can see this 2D array. So there are rows and there are columns, and when it converts into the matrix, it's all into the math science. So now whatever mathematical expression you are going to apply on that and do the process, and then the next part is like interpretation. So we'll go to the next part, but before that, just get your concept clear on image processing, that what exactly happens in image processing. So I hope this is clear. So the image was actual image which we can see and we can interpret. Let me ask you a question. If I give you this matrix, if I just give you this matrix, or if I give you this array, will you be able to understand the image? So
No.
no, yeah, because we cannot understand what these numbers are. I mean, you can use some techniques and then again convert from this matrix to the image, and then you can understand. But by looking at just this image, this array, you cannot understand what image it is. But computer, same happens with computer. If you give this image and don't convert it into the matrix, computer will not understand. So there is this difference between our understanding of vision and the computer vision. I mean, the human vision and the computer vision. So this is how we need to change the image into the matrix by using image processing. Let's go to the next now. So there is something called pattern recognition. Before going to pattern recognition, I would like to go to next slide and then I'll come back. So just now, because we explained about grayscale, I would like to explain about colored image. So there is something called RGB layers. What is RGB? Anyone? The answers in the screen.
It's a representation of a color.
Okay.
It's
And
a
what are
primary
those?
color.
What are those?
Red, green, and blue.
Okay, good. So R is red, G is green, B is blue. And what are those? Those are just channels. Channels, what is channels? So when we saw that grayscale image, it was very simple 2D array. So it was just having two colors. One is like not two colors actually, ranges from black to white, 0 to 255. And you can see only one matrix, like you can see only 2D matrix. Okay. But here we have three channels. So same thing happens from 0 to 255 for red, 0 to 255 for green, and 0 to 255 of blue. And combination of these three layers or these three channels will give you the composite RGB image. If you see this composite RGB image, you can see this image. You can see these colors, which are almost mixed up, and you can see one image. That's all. But if you convert this image into this layer, or let's say if you just break this image, convert is not the correct word, break this image into the layers, then you can get this blue layer, you can get the red layer, and you can get the green layer. And accordingly, you get three different arrays. So you can say 0 to 255 matrix for this green, for red, for blue, and the composition of this whole array is going to be multi-dimensional array that can be 3D. So that will be having rows, columns, and also these layers. So I hope you are able to imagine what is going to happen with the grayscale image and what is going to happen with the RGB, or let's say colorful image. Okay. So only the reason to go to this slide first is because I just wanted you to understand what is the difference between grayscale and what is the difference between RGB and how to process and what happens after the process. So after the process in RGB, you get the multi-dimensional array, and after the grayscale process, you get the 2D array. So because now I say that the 3D array is quite difficult to process because it has many numbers. It is going to have three different arrays, combination of three layers. So it is going to be little difficult to understand by machine because it has to go through all the layers. But then in grayscale, it is quite easier because it is just 2D array. So how in our school days also we were very much hating the 3D arrays. Same thing happens over here also. So yeah, let's go to the pattern recognition. Now, next thing is how after the process happens, after the image processing, how the computer understands the image, what exactly insights it takes from the image. So pattern recognition is nothing but now you have these all pixels, and each and every pixels, or let's say combination of few pixels, computer uses to understand the pattern. So what exactly pattern is there in the image? Let's say I have given you images of very oftenly giving example, that is cat and dog. Now in the cat and dog, let's say I have given you 20 images of cat. So by looking at 20 images of cat, you can easily recognize that how cat looks. So cat has the ears which are smaller than dogs. Also, it has a triangular ears. Any other pattern from cat? Anyone help me? So how cat is different than dog?
Whiskers.
Hmm. Okay.
Maybe hairs on the eyes.
Eyes, yeah, eyes can be yes, because hairs, I guess, both have sometimes similar.
Yeah,
Yeah. Also, maybe the body shape is also different. Like
yeah, some.
how if they sit and if you take an image, then it looks little bit different than dog. So see, we are able to understand the pattern. We are actually not understanding the whole image, but we are understanding the pattern. So let's say viscous is there. Okay, it can be cat. Let's say triangular ears are there, eyes shape is different. So then we are understanding, okay, this is a cat. Similar thing happens in computer vision also. Computer don't understand the whole image as it is. It just try to understand the pattern. It understand or it recognize the pattern and it keeps it in the memory. That okay, this pattern I have seen in the cat image. So this viscous pattern I have seen in the cat image. So what happens is like it breaks into the pattern. It breaks the image into the pattern and it analyzes this pattern. So let's say if you see this image, this animation over here, that the whole I guess is a face emoji, and see here is a face emoji, and it is trying to the computer is trying to analyze the pattern. So let's say the lower half, then the side. So by this, it will break this down into the small patterns. And these small patterns are going to be very essential in order to understand or in order to interpret what is that in the image. So this is how computer understands the image. We have already seen RGB. Now let's before going to this, I hope you guys are understanding what are the steps, what are the basic steps. So any doubt in this till this, you can ask. No doubt. Should we proceed? Okay. Yeah. Okay, then we'll proceed further. So let's go to the steps to create computer vision application. Now we understood what is computer vision, but now we have to use this to make the application, to make the end application. Let's say, as just now we took an example saying that cat and dog, classification of cat and dog. So for that, because we have already taken this in our last session also, saying that how ML steps, I mean, how many ML steps are there? Which are the ML steps? ML is like machine learning. What are the steps to follow to get the machine learning model or machine learning application? So similar steps we are going to follow over here also, because it is also going to be the same journey. So one is like step one is identify the business problem, identify what the problem you are going to solve. Step two here is like define success criteria, saying that okay, if there is a cat, you should define and tell your machine because you're going to teach the machine that this is a cat or this is a dog. So we need to define the success criteria. Third is determine the appropriate computer vision techniques. Now, this is little bit difficult for the people who have not any prior experience in computer vision application building. So for this, as I have mentioned over here, that Navan AI does it for you. So no code platform you can use to do the step three. So the step three, the step in the Navan AI called select model template, where you can actually get the base model. Let's say it can be image classification, it can be image detection. Now, what is image classification? What is image detection? That also I'll explain in the next slide. But it will determine the appropriate computer vision technique. So this is a very important step. Step four is collect and label the training and test images. So you need to collect the images, you need to label it in the proper way. If you are using the object detection, you need to put the bounding boxes, you need to denote that what it means. You need to tell the machine that okay, there here is the object and what it means. So this also you can do with Navan AI. You can do the dataset management. Step five is train and evaluate the model. So you need to train on top of your custom images, your data set, and then that also you can do with the Navan AI. Step six is deploy and test. Again, on the same platform, you can do deployment, you can do testing. And the last is iterate on the solution. So these are the simple 7 steps to do to make the computer vision application. Now let's go to the next. It's like what are the application? What are the basic applications or what are the types of application you can build on computer vision? So here, what we are talking about. So classification is something that you just get an image and you get a tag for that image saying that this is a cat. That's all. This is a cat. This image, I mean, in this image there is grass, there's a stone, I guess. Then we have some bush at background, and there's a cat. But because it is a classification model, it will only tell you what class it belongs to. That's a cat. Now let me ask you, if this is the image, and if I want to tell what is the class of this, then our computer vision model is going to be confused. Because with all this, let's say we have built the image classification model with cat and dog, and let's say cat, dog, and duck, and giving this image where the cat, dog, and duck all are present, there your computer vision classification model may not be able to give you. I mean, definitely it won't be able to give you all the classes. It will only tell you that, okay, maybe it will tell cat or maybe it will tell dog. That's all. It won't be able to detect all the objects in the image which you have made the classes for. So that is the one drawback if you want to use classification and you want to detect many classes in the same image. You should not go with the classification. Simple. So because classification is something which can only classify and give you the tag. Now something additional is localization. What is localization? The classification was telling you that there is a cat in this image. This is a cat. Images itself belong to cat. But in the localization, it will also tell you where the cat is. So the localization is nothing but it will draw this nicely looking bounding box over here. Sorry. And it will tell you the where the cat is. So this is what the cat. So computer says that, okay, here is a cat. And also it will give you the classification saying the cat. Now object detection is something that the case we just we discussed, that all the objects, let's say multiple objects are there, not all, maybe multiple objects are there, two objects are there, one objects are there, and in that we need to identify all the objects with their tags. So it can identify there is a dog with the blue bounding box, and then the duck with the green, and the cat. So cats are also, there are two cats. So this two cats also in the normal classification case, it cannot identify two cats. It will just identify cat. But here it is identified two different boxes with all other objects. So this is what object detection. So where to use object detection, where to use classification, where to use localization with classification, that you can get an idea from this image. So you can see here also I have mentioned that there is a multiple object cases. You need to go with this kind of a models. If there's a single object, you can go with these models. And then we have the instance segmentation where it will draw the boundary of the object rather than giving the bounding box, because bounding box comes with many, let's say if this blue bounding box, if you see some part of almost, let's say 80% part of duck is also there in the blue box. But if you see this image segmentation, so here there is a sharp boundary which has been drawn by the model and also giving the tags. So this is how different applications in computer vision. We'll see the more application into the deep. So let's go to the next is a very famous application saying that face recognition. Now what happens with the face recognition? As we saw that we capture a data, so image acquisition is going to happen, and from that image processing will happen. After the image processing, it will extract the pattern, it will extract the, or let's say it will recognize the pattern of what, pattern of the image and images of face. So let's say pattern in our face. So as we said for the cats, we can see here the eyes, we can see the eyebrows, there are different patterns, everyone has a different face structure. So by looking at those images, computer will analyze what are the patterns are there in particular person's face. It will extract the pattern and it will start comparing. So my pattern can be different from, let's say, uh, Shah Rukh Khan, or let's say Tom Cruise. So it will start comparing the different faces, and not exactly faces, but the patterns. And by comparison, it will understand whether the face is matching or not. So this is what the face recognition application, which is completely based on computer vision. And there are multiple parts and process over there, which has been given to capturing, extracting, comparing, and matching. So this is the one very famous application. Then the next is object detection. So similar thing, various places, even in the self-driven car, we use this. We use this in third umpire. So when you see any match, you get the third umpire, and you can see there are different graphics. It says whether the bat touched the ball or not. All this happens with the object detection. There are the sensors also involved, but nowadays, because of the enhancement in computer vision, you can do it just by the images or just by the videos. So this is what object detection is. You can see multiple detection happening over here. Let's go to the next application. Is again very famous nowadays, OCR. So this is what OCR is, that converts the image into the text. So if you see, if you just put the image, it will start identifying the text. So it will see that there is a boxes where it identifies the text and convert that into the text, which can be edited or which can be copied. So this is again very useful case. Then the next we have manufacturing defect detection and classification. So here, while manufacturing is happening, there are many applications saying that there and then itself it will identify the defect and classify the product into the healthy product or good product or the defective product. So that is also, it is showing the bounding boxes saying that it is a detection, and it will detect where the object has the defect. So this is also very important and very famous application in manufacturing industry. So next is like healthcare. In healthcare also, from so the computer vision, let me tell you that computer vision is not very new application or very new technology. It's there from 1963. It's just that nowadays it is getting into the boom, and it is getting into the um, almost in all industries. But even in 1963, 1965, there was some computer vision application. Although the techniques and the users of technique and the process was different, it was little bit older. I mean, it was little bit complicated. Nowadays, because of the ML and AI industry development, we have very much better and very much effective techniques in computer vision. But it is there from last, like, let's say 50 years. So in healthcare also, it was getting used in from last few decades, and nowadays again it is getting advanced. So it is detecting the problem, let's say this, by these image screening. So there is a detection and classification happening. Agriculture also, we can use detection and classification. There are a lot of drones nowadays, UAVs, which can be used to maintain the crop, or to um, give the pesticides to the crop, uh, identify the defective crop, or maybe what you say, that identify the crop yield, how much yield is expected from the crop. These all kind of applications can be made by computer vision. This is now one by one we are going to the newer applications. So these are again very much advanced application. You can see one is super resolution. Super resolution is, by this image you can understand that by getting the low resolution image, you can convert it into the high resolution. So how nicely it recreates the image. that you can see. And that is also we are going to have in our platform very soon. Um, then we have 3D avatar generation, and from the image, let's say from this image, it is going to get a 3D avatar for any purpose. So this is also mostly used in gaming industry. Then the next is 3D mapping. So 3D mapping is nothing but that you fly the drone or UAV from the area and it starts capturing the images. By these 2D images and some more data, it will convert whatever the map it gets, it will convert into the 3D map, and it will convert into the 3D model. 3D model in the sense 3D object, saying that the area or the path the drone has covered. So it can. This is also very much interesting application and very useful in many purpose. And then again, this is very much interesting. That is GAN. So you can see from this image, what happens is like it is converting, or rather, it is recreating the image through this input image. So see how it creates the image. It creates a completely new. It generates a completely new image. There are many applications which you can use this GAN, and that is also going to be available in our platform soon. So yeah, we are almost at the end of the session. But before that, before going to the end, I would like to know if there is a doubt or you want to say something. Don't hesitate to ask any doubt. Let it be very basic or let it be very advanced. We are happy to answer. No doubts? Okay, so that means you are following. Okay, so last thing is we are giving some tips because we saw that while seeing the usage of our platform, we saw the basic complaints saying that sometimes when people are using custom data sets or people are using custom images to train their model, so there are few times that they don't get good accuracy or they don't get good interpretation from the model. So what are the mistakes and what are the things we can improve? Those tips we are giving over here. So very first is the selection of data set itself should be done according to the case. So it should be such a clean that the image, let's say you are going to have a classification between, let's take one example from here, saying that there is a healthcare and saying the detection of the pneumonia and related disease. So here, when you create the different classes, image classification, we create different classes, and we are going to assign images into that particular classes. So while assigning the image, we need to make sure that the images are good quality. Like it should not be blurred because this is going to be very important factor. If the images is blur, then you understand after image processing, it will interpret the data from the image, which is not going to be very correct. And then the image, I mean, the pattern recognition itself will be wrong. So once it recognizes the pattern wrongly, definitely it will interpret the image in the wrong way. So to make it clear for the computer, try to give as much as good images to the particular class or to each and every class. Also have the balance of the image number of images in all the class. So don't do like cat and dog. So cat are having 500 images and dogs are having only, let's say, 100 images. Then again, model will be more deviated towards the images or towards the class where the images are, let's say, high in number. So that is again the mistake people do. While annotating the images or while labeling the images, try to collect all the labels all the information from the images. Then the main thing is kindly put the images into the correct classes so that uh, don't do mistakes in assigning the classes to the images. So these are the basic mistakes people do, and eventually they will get the model which is less secure, and which is less having the, I mean, they lose the precision. So these are few tips. Also, when it comes to the video and when it comes to the image, let's say you are collecting the image by your own, which is custom, and if you are using a camera or let's say device, that device should be appropriate for that particular use. So you need to look at focal length, you need to look at the frame per second. You need to identify first those values. You need to check whether your use case and those values are suiting with each other. And then you need to take action on, I mean, you need to understand which is the correct device to be used for your particular use case. So these are few tips which we wanted to give you. And after that, whatever problem you get, whatever support you need, we are happy to help. And that's all for the today's session. Let me know. We can wait for another 2-3 minutes for the doubt.
Okay, before we end, thanks, Ayush. That was a wonderful presentation. Thanks for that. And before we end or even take questions, I just have a couple of things to share. One is that any of you who wants to test or even create your own computer vision models without having to write any code, you can go to navan.ai, check out, read through the information, and you can sign up for a free demo. Also, signing up is free, so we'll show you a demo, and then you can start using the platform for free. In If you directly want to just see the demo, I've shared a link in the chat. You can go to the Calendly link and schedule the demo directly. And more importantly, please do share your feedback for the session. I share the feedback form link also in the chat box. So please do that. That helps us make the webinars better in the future. So that's it. And again, yeah, we can continue with the questions. If there are any questions, we can take them up.
I have one question actually. See, when we are generating a model, right? The whatever the model training and the deployments, what is your deployment platform actually? It is in SaaS model or what is the platform that we
Yeah.
need to host our models?
Okay. Thanks, Venkatesh, for this question. Yeah, I would like to answer this. So deployment comes with different platforms. The platforms in the sense different deployment you can do on the different platform of what your choice is. So we give Docker files to export, which you can use, and you can use the Docker file for any kind of deployment. Let it be on edge device, or let it be on any kind of server or on premises. It can be AWS EC2, it can be let's say GCP. Another way is like, if you don't want to deploy it by your own, we deploy it on our server and give you the endpoints APIs, which will be easy to integrate. 24/7 you get the support. So yeah, these are two things. And if you don't want to go with the Docker as well and API as well, then you can use a normal Python code which is used for the interpretation, and you can use the model file which you can download from your account and use the Python code which is available on GitHub, which we are giving the public repo. So yeah, these are the three ways.
Also, adding on to that, so Venkatesh, if you wish to use the API, then it's a SaaS model, and it's available for certain paid customers. But if you don't wish to use the API, if you're fine with the Docker image or the model files, then it's included with the free account as well.
For inferencing, whether we need a GPU compatibility or what is the requirement on that? Whether the
Okay.
models are which are generated, we can inference through CPU itself or we need a GPU.
So yes, you can deploy the model without GPU also. The only thing is when we use GPU is to accelerate the interpretation, the response time. So if you want it on the faster, then you need to use GPU. Both kind of Docker files you can get from the export. We'll make sure that on CPU as well as on GPU you can use. And very soon we are going to get the interpretation, so inference server, uh, which is called Triton inference server, uh, Docker file or maybe Docker image rather, which will be available for you to directly export, and you can use that inference server, which gives you optimization on GPU usage and also gets a faster response. So yeah, I hope this gives the answer for your question.
Yeah, thank you, team.
Thanks, Venkatesh.
Any other questions from anyone? All right, I think we can wrap up then. Yeah, doesn't look like others have any questions. So thanks everyone. Thanks for joining, and hope you all filled up the feedback form as well. And see you in the next webinar. So we'll announce our next webinar through our channels on Meetup groups or also on Eventbrite pages, on our Eventbrite account rather. So stay tuned and see you again very soon. Thank you.
Yeah, thank you for